Good afternoon. Thank you very much for being here. Welcome. I would like to dedicate this to my wife, who has to live with these ideas. To my daughters Leslie and Stephanie, who may witness this great endeavor in their lifetime. To all the scientists, engineers, explorers in a history that inspired new generations. To my good friends Bob Sick and Hugh Harris. To God, who gave me the possibility to dream and express these ideas, to all the people who will look at this paper, and to the Mars explorers. This paper is focused on the possible and logical steps for a Mars manned mission considering today's technology, emerging space vehicles, energy, propulsion systems, private and international involvement and experience gathered by unmanned and manned missions. The objective is to not go into the technical details, but to look at the big picture that will eventually identify the different technological resources available, what needs to be modified on them, and the elements that need to be designed and built. This is what we will be covering: the different options, the international cooperation, a lunar base as a prelude for a Mars manned mission, a Mars sample return mission, and how I imagine will be the first Mars manned mission. What is needed for this objective? A self-support space vehicle able to sustain life for at least 3 years, design a Mars lander, and all the equipment that will be delivered to Mars, and consider a Phobos and Deimos flyby. The idea of this slide is to illustrate that the mix of all these factors can produce a successful Mars manned mission as a result. The formula includes experience, new technology, and cooperation. The project is seen as a world mission, with the participation of different space agencies, private industries, and universities. I am considering two options: a Mars manned space vehicle that could be assembled in Earth's orbit, or that this vehicle will dock with a module previously launched and should be on Mars orbit when the crew arrives in the Mars crew vehicle. The following 3 slides explain the idea of the International Space Council, which is similar to the actual International Space Exploration Coordination Group organization. The final objective is to join efforts to reach the goal by distributing the work and costs, and extending the participation to universities and research organizations around the world. This by coordination of a chairman and with the complete commitment of the participants. Each agency, private industry, company, and scientific organization will decide how it can participate in accordance to their own program requirements, capabilities, and expertise. Can you change to another one? And the next one, please. Perhaps a good idea to approach the Mars manned mission will be to have a lunar space base built with modules needed to sustain life, and the ISS could be act as mission control center for it in order to identify the areas that need to be emphasized to reach the independence level required. The crew could arrive to this lunar space station in a vehicle capable of mission beyond Earth orbit, like the Orion space vehicle. The next few slides illustrate this concept. This slide presents the orbital changes to take the lunar space station to lunar orbit, in case the LSS is assembled on Earth orbit. Other option may be to send a single module to the Moon's orbit and from there build a larger station if needed. The crew could arrive later for a long duration mission that lasts more than 1 year. This is the LSS orbiting the Moon. From there, the crew could perform Moon and planetary observations, send unmanned probes to the surface of the Moon to gather samples, perhaps to perform a manned lunar landing, and could also be a place where a manned mission will study an asteroid captured by an unmanned probe and brought it to lunar orbit for analysis. This is a representation of the Earth with the ISS and the Moon with the LSS. A manned space vehicle is traveling towards the LSS. These two slides are to present the idea of continuous communication scheme between the LSS and the ISS or the MCC. This one shows 2 communication satellites in lunar orbit. This orbital path will allow that there will be at least 1 communication satellite in contact with the LSS, especially on the far side of the Moon. These satellites will transmit to the ISS and the Earth satellite network to retransmit to MCC and the ISS when they are not in a clear contact line. This same technique could be applied on Mars at some point. An alternative communication possibility could be to install on the Moon's surface relay antennas to receive and transmit information between the LSS and the ISS and Earth. As a previous experience for a Mars manned mission, an unmanned probe could be sent to land on Mars, collect some sample and return to Earth, alternatively to lunar orbit to avoid any possible contamination. This experience will give a complete view of the Mars expedition. This unmanned mission could take place at the same time the Lunar Base is assembled, if it is decided to do it this way. For the purpose of this presentation, this is not shown in detail. These slides show the unmanned probe taken to orbit by a multi-stage rocket. The last stage will be used to take the probe on its route to Mars. The objective will be to land on Mars, collect soil or rock samples, lift off from there, reach Mars orbit, and fire its engine to be directed to Earth. The specific plan for this mission has to be done considering landing technique options, landing places, surface exploration, and amount of material to be collected. The schedule for the mission is also a factor to be considered. The best date to reach Mars in a short period. How long should it be on the surface of the planet? The energy needed for a liftoff, and be able to leave the Martian orbit and be sent in a trajectory for an Earth approach. Once in orbit, slow its speed to be captured by the Earth's attraction or the Moon if it is decided to do it this way. For the purpose of this presentation, this is just a concept to consider. Now, this is an idea for a Mars manned mission. The following slides show the different modules that could be needed to assemble this Mars vehicle. The proposal is to prepare the vehicle in orbit that could be either docked to the ISS or not. Use the new launch system capabilities, new propulsion systems, and new manned vehicles designed to be used beyond Earth orbit. This is a concept, an idea based on what is being created today. All modules will have an approach and docking mechanism and small rockets for guidance to approach to the orbital structure. When it is near, it will be grappled by the RMS to be berthed with the ISS, just as it is done today with the Dragon and the Science. If the Mars vehicle is going to be assembled docked to the ISS, the first element that will be launched is the connecting module, which will be the middle component. Other two modules will dock with it. In addition to cargo vehicles, the crew space vehicle. It is similar to the Unity node of the ISS. In all cases, the module container will be sent back to Earth to be destroyed during re-entry, to avoid leaving additional debris in orbit. This launcher could be a central rocket with reusable SRBs. The next module that will be delivered is the living quarters module, shown here. This module will be used as living quarters and life support systems for the crew. It will have two docking ports, one on each end. One will dock with a connection module, and the other will be used temporarily for a Mars lander and later to dock with the Mars orbiting module if this option is chosen. This module has solar panels and batteries to supply electricity. It will have a remote manipulator system. This module will be used as laboratory, storage, water recycle equipment, and oxygen generator. It has a docking port on one end and an assembly structure with interfaces for the propulsion system on the other. The computer will be loaded with the information for the journey, orbital departure, and orbital insertion. This module will be docked to one of the connecting module ports. The launcher will be determined by the weight of the equipment and the supplies in it. Propulsion system. This element has the engines to accelerate the Mars vehicle en route to Mars. It will perform course corrections and also will slow velocity to be captured by Mars. It will be sent to Earth's orbit by a SLS heavy lift launcher. At the top, it has a structure to dock with the multipurpose module and the connections to the propulsion and guidance computers. The fuel could be liquid hydrogen and oxygen or other propellants that may be ready to use at that time. This module can be sent before the Mars manned mission to reach Mars orbit and activated from Earth. Its use can be as crew quarters and may include some supplies and instrumentation to measure the Martian atmosphere and weather conditions, among others. It will be launched on a 3-stage rocket of the SLS generation, a heavy lift launcher. It is like a hybrid module for unmanned and manned missions. The Mars lander that I have imagined here consists of a manned space vehicle, the size of the Orion space vehicle. This is internally a spherical container built with a light structure on the upper section and a supported structure in the lower section that will act as a launch platform for the return to orbit phase. It has 6 retractable landing pads and cameras to monitor the landing by the crew. This structure will have cargo containers to hold equipment that will be used during the surface exploration. This sphere is inside a container that has 2 parts, the heat shield and the landing mechanism, that consists of 2 parachutes and rockets for a soft landing, similar to the sky crane technique used by Curiosity, or the drop ship technique that is being tested by the European Space Agency. If the landing needs to be aborted, the heat shield will be jettisoned. The landing section will fire its rockets to move away, and the lander will start its engine to return to orbit. Once on the surface, the sphere will open in sections, exposing the crew vehicle, the ramp for the crew to reach the surface, and the equipment. In this case, I have included 2 electric standing scooters for the astronauts to explore the nearby area, and a greenhouse that will be left on Mars for controlled environment. The following slides illustrate the assembly process considering the 2 options, docked to the ISS and away from it. As mentioned previously, if the assembly is done away from the ISS, the first element that will be launched is the crew quarters. This is because it has an RMS that will be used to grapple the arriving modules to assemble the Mars vehicle. If the Mars vehicle is assembled docked to the ISS, then the first element that will be launched is the connecting module. Once in orbit, it will be guided to approach the ISS. It will be grappled by the RMS and docked to the PMA2 docking port of the Harmony module. The next module to be sent will be the crew quarters module. It will be captured by the ISS RMS and docked in the docking port of the connecting module near the ISS Kibo module. This will be the first module to be sent to orbit for an assembly away from the ISS scenario, followed by the connecting module. Following this, the multipurpose module will be launched, captured and positioned to dock to the port of the connecting module near the ISS Columbus module. The last module of the structure to arrive will be the propulsion module. It will be captured, positioned, and docked with the assembly structure of the multipurpose module. This assembly structure has all the signaling interfaces and hardware needed to send data to the propulsion module computer to control the main engine, firing, and the route correction that may be needed. The independent Mars module can be launched at any time when the Mars and Earth are in most appropriate positions for the journey. It will be controlled from Earth and programmed to reach Mars orbit. Once in orbit, it will be checked and activated to begin the observations of Mars. If all goes as planned, the Mars vehicle will dock to it when it arrives to the Mars orbit. As mentioned before, if the Mars vehicle is going to be assembled away from the ISS, the first element to be launched would be the crew quarters. Once in Earth's orbit, a crew will arrive to it to perform checklists that involves activating and testing systems and equipment. The crew can stay there to receive the other modules or return to Earth and be launched prior to the arrival of the following elements. Once the Mars vehicle is completed, the preparation for the journey will begin. This is the arrival of the Mars lander, supplies, system, verification, and finally the Mars mission crew aboard the Orion or similar space vehicle. The Mars space vehicle is now completed and ready for departure. But before this can take place, the Mars lander has to arrive and be tested. It is launched the same way as the elements were, and the final rendezvous with the Mars vehicle will take place approaching to be captured by the RMS. If the Mars vehicle is docked to the ISS, the Mars lander will dock at the end of the crew quarters module. and later be relocated to the connecting module. If the assembly took place away from the ISS, the Mars lander will be docked to one of the connecting module docking ports. At this point, the crew will test the systems on the Mars lander. Before the departure, cargo vehicles will be launched to supply all that will be needed during the journey. If it is possible, a cargo vehicle could form part of the Mars vehicle, keeping part of the supplies there, and could be used as a storage module. On this slide is shown how cargo vehicles could arrive to the Mars vehicle in both scenarios, just like it is done with the ISS. Finally, the crew that will do the journey will arrive in an Orion space vehicle, or one with similar capabilities. For the vehicle that is assembled away from the ISS, the crew may have been there before to receive the modules and supplies, although all the preparation can be done with different crew, not necessarily the one that will actually travel to Mars. At this point, everything is ready for the mission. The Mars vehicle will undock from the ISS if this is the case, and move to a safe distance in order to fire its engine to leave the Earth's gravitational pull. As an example, the Mars vehicle could leave Earth's orbit between November and December 2024 to reach Mars orbit in August 2025, following this orbital path. When the Mars vehicle reaches the Martian orbit, a decision will be made if it will dock with the independent module that was sent before, depending on the orbit of both and the propellant needed to adjust the orbit. For this presentation, it is assumed that all goes as planned and both parts dock in Mars orbit. After some time on Mars orbit, mission control and crew will determine when and where to land on Mars, the time length that the crew will expend there, and review the mission plan, areas to explore, equipment deployment, greenhouse activation, and when a decision is taken, the Mars lander will undock and begin its descent to Mars surface. First, it will suffer a fiery entry when it reaches the upper atmosphere. Then, the parachutes will be deployed. Then, the heat shell will be released. The landing rocket's ignition, and for the final approach and landing, I am considering the sky crane technique used by Curiosity. So when the landing pads touch the surface, the sky crane will be released and sent far from the Mars lander. Once on the surface, the upper path of the sphere is open, exposing the return vehicle and the tools that will be used during the exploration. Among them, the electric stand scooter for transportation or a buggy-type electric vehicle, the greenhouse and other tools to collect and analyze soil. The crew will come out the return vehicle to begin the exploration and install equipment to be left on Mars. One of them will be the greenhouse. This exploration may be as long as 1 week, depending on the crew supplies. Also, to be considered the time that will take to dock with the Mars vehicle. The purpose of this greenhouse is to determine if plants can grow in Martian soil in a controlled environment. The idea is to divide the container in two sections. One will have soil from the Earth, the other soil from Mars. Seeds will be planted on both sections. The greenhouse uses solar wind energy. The greenhouse uses solar and wind energy to charge the batteries that will activate the system to recycle water and the atmosphere. It will also adjust the light and temperature to avoid freezing. The idea is to use the plants that can survive in extreme temperature conditions, for instance, desert plants. After the exploration by the crew and installation of all the instruments, the crew will lift off from Mars towards the Mars vehicle in orbit. The return vehicle will approach and dock with the Mars vehicle. If the opportunity arises, other option will be to perform a flyby of Phobos and Deimos using the Orion space vehicle, not to land there, but to take a closer look at them and take some measurements of each one. The time has come to return to Earth. A decision has to be made whether the Mars vehicle will return with all its modules leaving the independent module orbiting Mars as it was when the Mars vehicle arrived, or leaving one module docked to the independent module to begin the assembly of a Mars orbit station. called here MOS-1. So the following crews can dock with these modules to continue the Mars exploration, and perhaps the departure point to begin a Mars colony and the exploration of Titan or Europe. The journey back to Earth could be something like this, leaving Mars between December 2026 and January 2027 to reach Earth orbit by July or August 2027. This would conclude the first human exploration of the planet Mars, another step in the exploration of the universe. If something like this takes place, there might be three active space stations: the ISS orbiting the Earth, the LSS orbiting the Moon, and the MOS-1 orbiting Mars. Thank you.
Okay, questions? Do you have any questions?
Have you considered the concept of a reusable Mars lander? Because I did a study starting 4 years ago that showed that if you build your vehicle to be completely reusable, then you only have to build one vehicle instead of two. And then that vehicle could be used over and over again to bring down additional equipment.
Okay. No, in this case, as this is just the first expedition, the only thing I consider is one to do the landing and return, but not reuse it. But that would be great to have it that way.
What type of work, what type of exploration do they do on the surface?
I think that just put all the instrumentation they have and just explore the nearby area, collecting samples and rocks, because it's going to be just a short time for this first expedition. I don't think they would have time to go further north to maybe to the polar ice caskets or something like that. So it's just going to be near that area.
What sort of radiation shielding methods for the transit journey have you, investigated for this particular mission?
Well, I think because 2 years ago I was trying to do something with the ISS, trying to reconfigure the ISS to form something like this. But it came to my attention that the ISS modules will not support all the radiation and all the micrometeorites that should find on the orbit and on the way to Mars. So these ones are all created for this objective, and I think they should have more, how do you say, more hard cover, yes, to resist all that.
Thank you very much.
Thank you.
Good.